so write this down. The title. No. Write down the title. Factor difference of two squares and perfect square trinomials. Now, this is really going to be two shortcuts. One of them is called difference of two squares. One is called perfect square trinomials. What word is in both of them? Squares. Now, so mathematically, we're not talking about shapes here. What do they mean, squares? What are those referring to? So we kind of abbreviate when we say squares. It's kind of assume that you know it means perfect squares. So we could say the difference of two perfect squares, and you can see here it says perfect square trinomials. We're talking about perfect squares. All right, I'm going to give you a list of numbers that are the perfect squares, and let's see if you can identify the pattern of what those what it means. So you can make a list of perfect squares. First one is 1. Next perfect square is 4. Next one is 9. And 16, and 25. So what do we mean by perfect squares? 1 squared equals 1. 2 squared equals 3 squared. 4 squared. 5 squared. So the crucial skill you need for these shortcuts is really being able to look at a problem that has like a 4 and a 16 or a 9 and a 25 in it. And saying those are perfect squares. In the same way, if I asked you, like, is 55 divisible by 5? Is 5 going to 55? Does 11 go into 88? Okay, so as quick as you can say, yes, you know, this is divisible by this, you want to be able to recognize, is this a perfect square? Yes. 25? Yes. 36? Yes. Okay, without hesitation. It's going to take a little practice, okay, but you want to get better and better at that. Okay, go ahead and finish this. Go a little longer. What's the next number?
36. 29.
The next perfect square. So what we're going to develop is an eye for perfect squares. So when we look at a problem, we're going to see, does it make up, or is it made up of these numbers? Does it have a 9 and a 64? Maybe it has a 49 and a 25 in it. That's going to be like a red flag in your brain to use the shortcut for about ready to go over. The important thing is that you know when to use it. Just like I asked you earlier, to use the X when, okay? You have to know when to use this. You can't just start using it on everything and say it works for everything. There's going to be conditions. All right, so let's go just a little bit further. Do 5 more. So after 100 would be
129.
okay. 13 and 14 squared. They kind of have similar answers. Okay.
96.
Look at the last two numbers, they've just reversed. 169 and 196, but it might make it easier to remember. And then the last one we'll do is 15 squared, which is 275. Now, chances are we're not going to see a lot of these numbers. They're going to be the more common ones that you would see on a regular old multiplication chart. But this is what we're looking for. So, the question is, let me show you the pattern, let you guys figure this out. I always like to let you guys figure it out rather than me just telling you, okay, do this, do this. Multiply those two together. Go ahead and multiply those together. If you want to use the box, that's fine. Let's see, what would you get? So remember, you're multiplying, right? So that's when these are on the outside. So we got, yeah. What do you get as an answer? Okay, let's just wait a little bit longer. Okay, ready? Okay, go ahead. What's the first square? 49x squared, and then and 28x positive, and so our final answer, you notice how the diagonals equals 0 cancel out. So the question is, can we do this backwards? So this is the multiplying, that's the forward direction. Factoring is when we do it backwards. So if I give you this as a question, can you come up with both of these? Okay. What are some relationships you see? Anything? 49 is 7 and 7, so 7 squared is 49. 16 is 4 and 4. Okay. You notice that this is a subtraction sign here, and over here 1 is positive and 1 is negative. So let's see if the pattern is true for more. Let's do another. Let's see here. How about 5a minus, or 5a plus 11, and 5a minus 11. Make a prediction on what you think this should multiply to, and then go ahead and check it for sure. So we're looking for patterns here. We're looking to see can we get the same answer just by looking and observing a pattern as opposed to writing every little step out. Because if a certain pattern occurs all the time, you may not have to spend the time to show all the work. All right. So, did anybody have a prediction what this answer is going to be? What?
Oh, 25 squared.
100 and?
Oh, 21.
21. Very good. And we can verify that here. We'll get 25a squared. Here we'll get negative 121. Here we'll get a negative 55a. And here we'll get a positive 55a. So once again, they cancel out. So you can see we have one. If one is positive, one is negative, they'll just multiply like this with a subtraction, because a positive times a negative is a negative. So when we're going the reverse direction, you have to keep that in mind. We have to have perfect squares. So the numbers here have to be on this list. So if one of them is like 25a squared, another one is minus 3, this shortcut will not work. If it's 25a squared and it's plus 9, this shortcut will not work. So you have to have both conditions. You have to have perfect squares, and it has to be a difference. That's why the name of the section that you wrote on the top of your paper is a difference of perfect squares. Subtraction means difference. Okay? That means a difference, subtraction. Yep.
Is it not a perfect group, though, okay?
Say again?
Is it not a perfect group? I mean,
Yes, but it's not but it only works if this is subtraction. So if they're both perfect squares, that's great. But if this is a subtraction, it's not a difference of perfect squares. So it's kind of like, when do you use the x? Okay, it's when you only have 3 terms. When do you use this shortcut? It's when you have perfect squares and subtraction. You gotta have both. One of them is not good enough. And then hopefully we can save some time. What this does is just eliminates the box. So hopefully we will not have to do this at all. If we can look at the problem and see, yeah, 25 is a perfect square, 64 is a perfect square, 81 is a perfect square. You have to be able to look at the question though and see the perfect square. Just like if it was, trying to find something divisible by 5 or 11. Alright, so would this work? Does this fulfill the criteria? Yes. So you're thinking in your head, are these both perfect squares? Yeah, that's 3 squared, that's 2 squared. And is it a difference? So yes, that means it's a difference of squares. So what would the pattern be? Huh? Go ahead and write it down. Say what you think. Write it down. Write it down, write it down. So 9 is a perfect square, so we're going to have 3x and 3x. 4 is a perfect square, so we'll have 2 times 2. And then what are the signs here? Positive and negative. Can you do a negative and positive? Yeah, that's fine too. Just by a general rule, I always put the positive first. Later on, what's going to happen is that you might do this several times. It's a little bit easier if you write the positive first and the minus second, but it's not wrong. Good. Just practice. Nope, not there. There we go. There we go. Can we change the look just maybe a little bit? Is it okay that it's n to the 4th? Yeah, because we still have a perfect square. It's still a 1, right? That's a perfect square. And we have 100. So we have 2 perfect squares, and we have a difference. So yeah, it still works. It's just instead of n and n, we're going to have what? N squared. Yeah. N squared times n squared is n to the 4th. And then, of course, plus 10 and minus 10. So the pattern works as long as you have those 2 conditions. But you got to have both. What about 11? Does that have? No. Yeah. 98 is not a difference. It's not a perfect square. Neither is 200. What we forgot to do something. Right here. Yeah. So before you say yes or no, difference of squares, before you do that, do the GCF, which in this case is 2. Right, 2 goes into both of these. You want to do that first. How many times does 2 go to 98? What's 98 divided by 2? 4?
No.
Over here, try it.
49. 49.
49.
So like 3 times.
Is 49 a perfect square? Yes. So you may not have it initially, but now you can go through, once again, notice how I left that GCS in front. Now you can go through and you have 2 perfect squares that are being subtracted, that's a difference of squares, and now you can complete the problem. So you're always looking for these numbers, and in some sense you're looking for multiples. So you know 49 is, and now you know, well, if you see a 98, that's the same as 49 times 2, so that still might work. So 49n squared, we have 7n and 7n. 100, we have 10 and 10. And then one's positive, one's negative. It's okay if we switch the order around. I know we usually have the variables first, but like on this one, what number could we take out with GCF? So you can see if I take a 4 out of both of them, I'm left with 2 perfect squares. So you want to be thinking, yeah, 2 goes into both. 2 goes in there. Maybe 9. But you also wanted to think, well, I want to have perfect squares left over here. So factor out the number that will leave me with perfect squares. And then, of course, you can finish the problem. And don't mind that it's in reverse order as far as the variables. It's the same pattern. So since the hundreds first, we'll have the tens first. That's okay. And the 9v squared is last, so we'll have the 3v's last. And that's okay. The signs work the same. One's positive, one's negative. And we could do more, but that's okay. I think we got the picture. So you're practicing this. I'm going to show you the second one because the instructions were what? Difference of squares and what was the other one? Yeah, perfect squares. I'll show you what that means in a moment. Let me pass out the work. Just pop it up. So. But when you get to number 3, you'll notice, well, that's not the difference of squares. There's some here that you can still use a shortcut, but it's not the same. Still use a shortcut, but it's not the same. But it's similar. What do you notice about the first and last number of number 3? What do you notice about both of those? What are they? What kind of numbers are those?
Oh.
Those are perfect squares, yes. So here's the difference. You're going to do the same process. If you recognize there's perfect squares here, you're going to do the same process as you did on number 1. Here's the difference. Okay, so 5b times 5b is still 5b. Write this down. That's still true. 4 times 4 is still 16. But here's the difference. We're going to get a 40 in the middle instead of a 0. That's why there's no number in the middle here, because it's 0. So the way you get that 40 is if they're both. If they're both positive, you'll get the 40. So you'll have 5v times 4, which is 20v, and you have 5v times 4, which is 20v. So it's kind of like the diagonal, they're both 20v, so it adds to 40. But we can still use a shortcut. So here's the difference between them. When there's 2 terms and they're different, they're both different squares, you'll have one positive and one negative. Okay. But if you have 2 perfect squares with a term in the middle, they'll both be the same sign as whatever this is. They'll have the same sign as the b value. Okay, so in this case it's positive 40, so these were both plus. We can look over here to number, what was it? Yeah, I guess let's go to 16. If we look at 16, by the way, what's the first step on number 16?
Take out 3.
GCF. So that has not gone away. So we have to recognize, there's a 3 that goes under all of these. Do that first. All right. So we have x squared minus what?
4.
Plus 4. And then we can go on and factor this. So this is a 1, this is a 4. And we could do the x in the box as well, but we might get lucky. X times x is x squared. 2 times 2 is 4. And this time we can see how it's a minus. So it's 2 signs of minus. Double check, does it work? So we can go through and see, yeah, negative 2x and negative 2x does make negative 4x. So yeah, that does work. If it didn't work, we just have to put it in the box, or put this in the x like we did yesterday and the day before. So they're nice shortcuts, but we can't use them all the time. And if you feel more comfortable, just go ahead and put it in the x and put it in the box. If you're not sure whether you should use it or not, you can always just put it in the box and get an answer. Here's another way you might see this answer. Just a little side note here. X times x equals what? X equals x squared. So whenever you have the two of the same thing multiplied, you can write it as that thing squared. Right here we have two of the same things being multiplied, so you might see this answer then like this. Means the same thing. So really today is all about lazy mathematicians. Okay? Lazy mathematicians will say, if I can find a shortcut that always works, I'm going to do it that way. And that's what these are about. Also, lazy mathematician doesn't want to write out x minus 2 and x minus 2. They'll write x minus 2 squared. But they know it means this. Keep that in mind. Today is about just taking a faster shortcut, but knowing when to take a shortcut, not just every problem from now on we always take a shortcut. So we have to know, first of all, we have to be able to identify perfect squares. We have to be able to see 36 and 100 and think, that's a perfect square. That's 6 squared, that's 10 squared. And you have to identify that it's a difference, it's subtraction. Right here, like a number 8, you have to always start with, is there a GCF? Even right here, you have to start with, is there a GCF? Because you can take a 4 out from both of these. Notice how we factor a GCF out from a difference of squares, and we still have a difference of squares. We're just 9 and 25 now. But we have to get really used to doing that. What number goes into 50, 60, and 18? Probably just 2. Yeah. Always start with that, and you never know. You might end up with a problem that you can take the shortcut. So again, you're seeing 36 and 100, that's a red flag. Here, after you do the GCF, you're seeing 25 and 9. That's a red flag, 2 perfect squares. So you know I might be able to take the shortcut. If you really didn't want to, you could go through and you could do the x. 25 times 9 would be 225 k squared. And then you'd have 30 in the basement. You'd have to find 2 numbers that multiply to 225 and add to 30k. Do the x, do the box. You'll still get the same answers. We're just hoping you can get that same answer through a pattern instead. All right. Try to finish the front. You'll have 10 minutes to get in tomorrow to finish it up, though. Have a good day.
I have no